In your video notes today, there really are not too many fill in the blanks. There are only 2 on this side, and there are only a couple of problems to do on the other side. So I just want to talk about a couple things really here. The first thing we have is that the measure of an exterior angle of a triangle is greater than the measure of either of its corresponding interior angles. So both of these will be true here, where it says the measure of angle 1 is greater than the measure of angle A here, and the measure of angle 1 is greater than the measure of angle B here. Remember, we said in our previous notes that the measure of angle 1 is equal to A plus B, and since neither A or B can be 0, in order for it to be a real triangle, the measure of angle 1 has to be bigger than both the measure of angle A, and the measure of angle 1 also has to be bigger than the measure of angle B. So our next part here talks about the angle-side relationships in triangles. This one says that if one side of a triangle is longer than another side, then the angle opposite the longer side has a greater measure than the angle opposite the shorter side. And 5.10, this is pretty much our reverse of 5.9, saying that if one angle of a triangle has a greater measure than another angle, then the side opposite the greater angle is longer than the side opposite the lesser angle. Really what this is saying, as you see down here, is that the largest angle will go with the longest side, the smallest angle will go opposite the shortest side. And then in this case, our medium angle here with C will be across from our medium side AB. So again, biggest angle B is across from our longest side AC, smallest angle A is across from our smallest side BC, and our medium angle C is across from our medium side AB. We'll always kind of have that ratio, where biggest will go with biggest, middle will go with middle, smallest will go with smallest. So for our triangle inequality theorem, basically to have a real triangle, any 2 sides of the triangle have to be bigger than the third side. So in this case, PQ plus QR has to be bigger than PR, QR plus PR has to be bigger than PQ, and PR plus PQ has to be bigger than QR. Okay, so our hinge theorem here says, in a lot of words, basically if you have 2 sides that are congruent and the angle between them is different, the one with the bigger angle in between will have a bigger side opposite it, right? So in this one, A is 43, so BC is going to be bigger than GH because F is only 30 degrees. We also have the converse, which again, in a lot of words, is pretty much saying if PQ is longer than JK, then R will be greater than L. That's all we're really saying here. So in these 2 problems down below, we can write an inequality here to say that GF is greater than FE. Remember, since they don't have the marks above them, that this is the measure of GF, so the length of this is greater than the length of FE. Because we can do hinge theorem, because HF is congruent to itself. For this one, again, BD is congruent to itself, so we have a hinge theorem set up here. And we can say angle ABD, the measure of angle ABD is greater, this is a greater than symbol, not an angle symbol, than the measure of angle CBD, because AD is bigger than CD.